of cow spinal cord, and we can, analogous to the model itself. So just as we can observe the meninges, dura, arachnoid, and pia mater, we can see that here as well. So within my hand here, this would be the dura and the arachnoid matter of the meninges. And if you look really closely, you'll see that the pia mater is still tightly covering the white matter of the spinal cord. Likewise, I would encourage you to observe just inside or just under the pia mater. See that dark blood vessel that runs right through here? That's the same as this dark red vessel that you see right here on the model. We call this the spinal artery. The spinal artery is just anterior to the anterior median fissure. So an anterior median fissure is always found on the ventral side of the cord, and we have a posterior median sulcus, and a sulcus is just a shallow groove. So this is by far a much more elaborate or distinct marking of the cord. So you can see anterior median fissure here, as well as the posterior median sulcus here, and generally the spinal artery is found, within close proximity to the fissure. So if you were to see this piece of spinal cord as a test resource, if you note that the spinal artery is visible, you know by default this has to be the anterior or ventral side of the cord. Consequently, you would be able to infer this nervous tissue that you can see here and here. Is that going to be facilitating motor or sensory information? Motor, isn't it? Because motor is always on the ventral side, as opposed to the posterior or dorsal side. You can see that neural tissue here as well as here. So this is the dorsal or posterior side. This is the ventral or the anterior side. Likewise, in cross section, you can see the gray horns. See that little kind of a butterfly shape or H shape? You can see the gray matter on the inside surrounded by the white matter on the outside. Now this material has been preserved in fluid for some period of time, so the colors are a little bit skewed, but white matter is always on the outside, gray matter is always on the inside in the spinal cord of a mammal. Likewise, we can see meninges here, as well as the pia mater closely bound. That's a pretty good place to see it. You can see the pia mater, very thin, delicate membrane. And we know that central to the gray commissure is where we would find the central canal itself. So this is but one of those 31 pair of mixed nerves that arise along the entire spinal cord. So how many pairs of spinal nerves does a cow have, or a horse, or a pig, or a dog, or a cat? 31.
So it's just all mammals?
All mammals. Pretty much. Yeah, pretty much. Many of the body systems of mammals are very, very similar. The only exception to that, I would think, like digestive systems can vary a lot in mammals between, say, ruminants as opposed to animals with a single stomach. But many body systems are like vascular systems and endocrine system, that sort of many body systems, nervous system, skeletal system. Very, very similar across the board. Digestive is one of the few where you see a lot of, where you would see some variation. But so we have 31 pair of spinal nerves, mixed nerves, that arise along the entire length of the spinal cord. So on test day, normally I rely on either preserved tissue such as this, or the model, or some sort of a colored illustration similar to what I've drawn here on the board, and you just identify wherever I put a pin, just any of these various terms, structures that we've just identified, and that's the way we'll do that. So, what else we have? Well, I've decided, normally we do this when we do this in a normal semester, we're only doing one lab exercise for the whole day, but since we also have to include